Okay, next we're on to part 113, which is line 18A, 3i, magnetic dipole moment, multipole Wow Seti. And there's the equation for it. Again, these are terms that came up in the line 18A data, and I'm just A3 actually, the line 18A3 data, and I've broken down the words to see what they mean. So the magnetic moment of a magnet is a quantity that determines the force that the magnet can exert on electric currents and the torque that a magnetic field will exert on it. A loop of electric current, or a bar magnet, an electron, a molecule, and a planet all have magnetic moments. Both the magnetic moment and magnetic field may be considered to be vectors having a magnitude and direction. The direction of the magnetic moment points from the south to north pole of a magnet. The magnetic field produced by a magnet is proportional to its magnetic movement as well. More precisely, the term magnetic moment normally refers to a system's magnetic dipole moment, which produces the first term in the multiple expansion of a general magnetic field. The dipole component of an object's magnetic field is symmetric above the direction of its magnetic dipole moment and decreases as the inverse cube of the distance from the object. Now, I had to look it up to see what it was. After I read all that, I still don't understand what it is. I'm sure it'll clarify itself as we go along, but this is what it looks like. And it's talking about an electrostatic analog for a magnetic moment, two opposing charges separated by a finite distance, positive and negative. And then this came up too. I don't understand what it means, but so I'll put it up. It's in the data. Figure 1 illustrates the quantities needed in the multipole theorems. The potential at point X, ER3 is due to mass at point Y. I brought up the Y and the R because that came up in the alien message equation, so I thought, well, maybe it means something. So it's talking about a reference point, and Y is the angle between the vectors, and also there are quantities. So, and it says the multipole theorems produce an expansion for 1R in a region of analysis outside a sphere. The theorems are: multipole expansion, provide a multiple series upon representation valid outside a local sphere. Local expansion, provide a multiple series representation valid inside a local sphere. The ability to sum individual expansions to obtain the multiple expansion of a potential depends on these expansions having a common reference point and a common region of convergence. If they do not, we must sift the series to a common reference point using the lemmas that follow. Translation of a multiple expansion. Shift the coefficients of a multiple series representation valid outside a local sphere when the reference point is shifted within the sphere. Conversion of multipole into a local expansion. Shift the coefficients of a multiple series representation valid outside a local sphere when the reference point is shifted outside the sphere, and convert the multiple coefficients to local expansion coefficients. Remember, coefficients came up before. They're coming up again here. Multipoles come up before too. Translation of a local expansion. Shift the coefficients of a multiple series representation valid inside a local sphere when the reference point is shifted within the sphere. So these are the things that come up. Again, I'm still lost. I don't know what it means. But that's for line 18A, 3i. And I'm going to do the research on the next one, and then I'll film it.